For most of human history, the Milky Way looked permanent. The stars changed positions so slowly that the galaxy felt less like a place and more like a fixed backdrop. Something that would outlast every civilization, every language, every memory. Then, astronomers started measuring another galaxy. Not a distant blur lost in the darkness, but Andromeda, a giant system hanging beyond the edge of the familiar sky. As observations accumulated, a pattern emerged. Andromeda was not simply nearby, it was moving. That movement changed the meaning of the night sky. A galaxy drifting through space is one thing. A galaxy moving toward your own is something else entirely. The Milky Way was no longer a stable object frozen in place. It became part of an unfolding event already in progress. The consequence was difficult to ignore. The future shape of our galaxy was not waiting for humanity to decide anything. Motion was already carrying both systems somewhere new. Which raises an uncomfortable question. How can anyone possibly know where two galaxies are going billions of years before they get there? The easiest way to dismiss a prediction is to imagine a mistake hiding somewhere inside the measurements. Maybe the numbers are incomplete. Maybe the motion only looks threatening because the picture is blurry. Maybe a small error today becomes a completely different answer later. So the measurements continued. Years passed. Better observations arrived. Then more arrived after that. Each new set of data acted like a filter. Possible paths that once seemed reasonable began disappearing from the board. A trajectory that worked before no longer matched the evidence. Another possibility survived for a while, then failed the next round of measurements. The process repeated again and again. What made the situation uncomfortable was the direction of the trend. Every new measurement removed another escape route. Not one possibility, not two. The list kept shrinking. Every improvement forced the prediction through a narrower opening. Each update made the future look less negotiable. The prediction was no longer branching into more possibilities. It was being squeezed into fewer and fewer paths. A prediction can survive uncertainty for a long time. What becomes difficult is watching uncertainty itself begin to disappear. By this point, the debate had shifted. Few people were still asking whether Andromeda was approaching at all. The remaining question was narrower. How many alternatives were actually left? And what observation would finally be precise enough to eliminate them? The narrowing process eventually reached a different stage. Instead of asking whether the data was good enough, astronomers began using better instruments to reconstruct what the future should look like if the measurements were correct. The picture became sharper. The motion of Andromeda was no longer represented by a vague range of possibilities. Observations from the Hubble era provided a level of precision that earlier generations simply did not have. Different futures could be tested against the data. Some survived. Others did not. Predictions that once felt speculative started behaving more like a coherent map. For the first time, it seemed possible to look billions of years ahead and trace where both galaxies were likely going. That changed the atmosphere around the problem. The uncertainty that had dominated earlier discussions appeared to be fading. Instead of a collection of competing possibilities, astronomers now had a model that connected the measurements into a single future. For the first time, the future stopped looking like a guess. The measurements pointed in one direction, Independent reconstructions pointed in the same direction. Evidence collected through different methods was beginning to converge on the same answer. At that point, it was tempting to treat the problem as solved. The answer seemed to be sitting on the table. And that created a different kind of discomfort. The prediction was becoming easier to trust, but not easier to escape. Yet something remained strangely absent. Even with a model powerful enough to reach billions of years into the future, scientists still stopped short of claiming absolute certainty. The model looked strong for a simple reason. The better the observations became, the harder it became to make the prediction go away. For a moment, it seemed like the remaining uncertainty was simply waiting to be measured away. But that confidence eventually ran into a limit. Measuring where two galaxies are today is one problem. Predicting exactly how every influence will accumulate across billions of years is another. As astronomers pushed farther into the reconstruction, additional influences began appearing around the edges of the calculation. The picture remained coherent, but it stopped behaving like a perfectly sealed system. A tiny influence that seems irrelevant today can keep nudging a trajectory for millions of years. Given enough time, even a small push can matter. The effect was subtle, but impossible to ignore. The prediction remained stable. The model still worked. The overall direction did not suddenly collapse into confusion. What changed was the expectation of perfection. Better measurements had removed enormous amounts of uncertainty, but they had not removed uncertainty itself. That distinction matters. A weather forecast can be useful without describing every cloud. In the same way, a long-term galactic prediction can remain trustworthy without becoming absolutely certain in every detail. The future was no longer invisible. But it was not fully settled either. The old belief quietly failed. More measurements could improve confidence. More measurements could narrow possibilities. But no amount of precision could turn the distant future into something humanity could actually control. Which leaves a more uncomfortable problem. If complete certainty remains out of reach, what allows anyone to say that it is already too late to stop what is coming? Look at Andromeda again. The most important thing in the image is not the galaxy itself. It is the motion hidden inside it. For generations, the Milky Way felt permanent, a structure so large and so familiar that it seemed immune to change on any meaningful scale. The night sky encouraged that illusion. Everything appeared stable. Then the measurements accumulated. The motion was tracked. The possibilities were tested. Alternative paths gradually disappeared. Better observations transformed a distant object into a future event already underway. The remarkable part was no longer the prediction itself. It was the realization that knowing about the process did not create the ability to stop it. That is the real discovery. Not that two galaxies may eventually meet. The deeper consequence is that humanity can identify a change so far in advance that no future decision meaningfully alters the fact that the process is already happening. The Milky Way stops looking permanent. It starts looking temporary. A familiar arrangement caught in a longer process that was already underway before anyone knew it existed. Andromeda is no longer just another object beyond the horizon. It becomes evidence. Evidence that part of the future is not waiting to be chosen. The conditions shaping it already exist. The motion already exists. The trajectory already exists. Long before the event arrives, the evidence arrives first. The image never changed. What changed was the realization that part of the future was already visible, and it had been moving toward us the entire time.